Hi everyone. In this video we are going to see about informed search. The otherwise called as heuristic search. So here the evaluation function is calculated in each and every node before taking the decision. In this video we are going to see two types of heuristic search, that is greedy best first search as well as A star algorithm. So let us see the example. This is the example. Here S is the start node and also G is the goal node. There are so many paths, and along with that we will having they will give the straight line distance, that is the distance to reach the destination, that is also given as a straight line distance. Based on that we will take the evaluation function. So here in greedy best first search, evaluation function is f of n is equal to g of n. So that is a straight line distance to reach the destination node. So let us see greedy best first search in detail. So this is the evaluation function, and this is a straight line distances. So first we are in the starting node, and from the start node we have three adjacent nodes. So we are creating three child nodes and A. Along with we are calculating the evaluation function of A. The evaluation function of A is 7. Why? Because you can see here the straight line distance of A to G is 7. So f of n is equal to 7. And next child is B, and here f of n is equal to 10. Similarly for C, f of n is equal to 20. So this we have taken from the straight line distance. And here among the three nodes, A is having a shortest distance, so we are choosing that path. And again we can find the child nodes in A. So A is adjacent to D as well as A is adjacent to S. So for D the straight line distance is 1, and for S the straight line distance is 10. So here again the minimum one is D, so we are evaluating that one. And the next adjacent node for D is F as well as A, and here for F the straight line distance is 1, and for A the straight line distance is 7. So here the minimum distance is 1, so that is selected. And from F we have the path to final goal node G, and the evaluation function is again 1. So we are calculating the total cost. So the path we have chosen is S to A to D, and D to F as well as F to G. And the path cost is from S to A, the path cost is 3, then A to D is 6, then D to F is 1, and F to G is equal to 1. So therefore it is equivalent to 11. So this is the total cost. And next we see about A star search. In A star search, we are taking the evaluation function f of n is equal to g of n plus h of n. The same problem we are using. Again we are taking the straight line distance. So here there are two parameters we are taking in the evaluation function. One is g of n and another one is h of n. G of n is straight line distance, so the distance from a particular node to the goal node, and h of n is the distance traveled so far. So from the starting node to the till node, what is the distance covered, that also we are taken in the evaluation function, so that we can get the better results as well as optimal results. But in this case we may get same type of results. So let us assume yes. So here S is having three child A, B as well as C. So for A, f of n is equal to 3 plus 7. 3 means from S to A it takes the distance 3, and from A to G it is 7. So the total distance is 10. Then for B it is 2 plus 20. So from S to B it is 2, but the destination distance is 10, therefore 12. And again C we have 1 plus 20. So 1 plus 21 means S to C is 1, and we are taking the straight line distance, so it is 21. So here again A is minimum, so we are choosing that path. And here the child nodes are D, as well as A. So A is adjacent to S as well as D. And if you take f of n, the distance covered from S to A is 3 and A to D is 1. And again the straight line distance is 1. So therefore totally the value of f of n is 5. And when you take S, f of n is equal to 3, that is S to A 3, again A to S 3 plus straight line distance 10. So here again minimum is D, so therefore we are evaluating that one, and here f is equal to 3 plus 1 plus 1 plus 1, that is from S to A it is 3, A to D is 1, D to F is also 1, and the straight line distance of F to G is also equivalent to 1, therefore the evaluation function we will get 6. A is adjacent to D is adjacent to A, therefore f of n is equal to 12. Here again we can choose the smallest one. So therefore we can choose this path F and we can reach G because G is the goal node and we are stopping the searching process. And here again we can to calculate the total cost, we can follow the same path. So in this example both greedy best search as well as A star algorithm will yield a same result, but there is a difference in evaluation function. When you try with other problems, we could get better results of A star when compared to greedy best search. Thank you all.